In this section of the module, we will be discussing the Common Core State Standards for Mathematics. The Common Core State Standards for Mathematics is a set of standards progressions consisting of mathematical content and the practices of such content in process with one another. It is important to think of mathematics from a K through 12 perspective as a progression and not as a set of individual concepts in each grade level. In the CCSSM, math is not put into individual silos, but rather understood in process to the learner. So what does it mean to think of the content standards in process with the practice standards? Viewing the 6 practice standards can be very helpful because each of them apply to all learners of mathematics. Here you can see the 6 practice standards as mandated by the CCSSM. Take a moment to think about how often your students are utilizing these practices. Also, think about how much you encourage students to do the same. Do you find some practices more challenging to implement than others? How does one adopt a view of mathematics that spans across grade levels? The easiest way to do so is to think about the trajectory in which your students have started and will continue to be on during their educational experience. What does a standards progression look like? Choose a particular concept beginning in kindergarten. View that concept from a K through 12 perspective rather than isolating it into a particular grade level. By taking a progressions approach, teachers can make even more informed decisions about how to help students. A perspective to remember about the Common Core State Standards for Mathematics is the overall progression in which a student must know the mathematical content. For example, most of the mathematics that must be learned is from the perspective of number and operations. Although algebra, geometry, data analysis, and measurement are all included, each are in service of number. So what does this look like for a student with learning disabilities? Let's take our example of James and look at one element of mathematical content from a K through 5 progression rather than identifying his issues in a piece-by-piece fashion. It is likely that James is missing fundamental components of place value. So let's discuss the holes in his thinking in a way that helps teachers see how place value builds on itself and then apply that to James. Beginning in early grades, students are expected to compose and decompose numbers from 11 to 19 into 10 ones and some further ones by using objects or drawings, and record each composition or decomposition by a drawing or equation. Students must also understand that these numbers are composed of 10 ones and 1, 2, 3, 4, 5, 6, 7, 8, or 9 ones. After students have mastered composing and decomposing numbers with pictorial or numerical representations, they are then expected to start understanding what is within a number. In the case of James, we know he is able to perform basic operations. However, it would be advantageous to assess his number sense about his flexibility within numbers. For example, according to the first grade place value domain, students need to understand that 10, 20, 30, 40, 50, 60, 70, 80, and 90 refer to 1, 2, 3, 4, 5, 6, 7, 8, or 9 tens, and 0 ones. Relying on the practice standards, asking James to explain the different ways he can make 30, for example, would be a helpful assessment tool. Can he reason through the different ways, or does he simply rely on rote counting? In the second grade, students are expected to decompose larger numbers, as in 706 equals 7 hundreds, 0 tens, and 6 ones, displaying various numbers for James accompanied with manipulatives such as base 10 blocks, counting cubes, or even an arithmetic rack, also known as the Reckon Rec, would assist in finding out the extent to which he can recognize the various positions of numbers. In third grade, James would have been using his knowledge of place value understanding to round whole numbers to the nearest 10 or 100. The size of numbers students must perform operations with become much larger during the third grade year. This is where James's understanding of place value may be faulty because many students struggle with place value as the numbers get larger. Building on this knowledge base of place value, the final 2 years of elementary school involve writing and reading multi-digit whole numbers using base 10, number names, and expanded form. Students are also asked to read, write, and compare decimals to thousandths. Depending on what is realized about James's number development, grades 4 and 5 might be targets for James to reach as more is understood about his issues. The standards progression just described is one example of how a student needs to experience place value in the elementary years. In the example of James, it is necessary for his 6th grade teacher to have a fundamental understanding of place value in terms of the CCSSM from an elementary perspective in order to understand the proper interventions needed.